The day was May 10th, 1940. The German Wehrmacht was not just invading France, it was demonstrating a revolutionary form of warfare known as Blitzkrieg, a lightning-fast, coordinated assault that combined air power, motorized infantry, and heavy armor into an overwhelming psychological and physical shock.
Its speed and destructive power were a testament not just to military genius, but to the methodical, grinding industrial capacity of the Third Reich, which had been secretly preparing for this moment for years. The spearhead of this attack was the Panzer IV medium tank, though it was often preceded by the lighter, faster Panzer III variants. The Panzers, having broken through the seemingly impregnable French defenses at Sedan, were now racing unimpeded towards the English Channel, executing a maneuver that bypassed the main Allied armies and effectively sealed the fate of Western Europe in days rather than months. The surprise was absolute, the tactical success overwhelming, and the psychological impact on the unprepared Allied forces was devastating.
This Panzer IV, weighing 25 tons and armed with a short-barreled 75mm KWK-37 L-24 cannon, was a finely tuned machine, conceived with a philosophy built on engineering precision and tactical flexibility. It was designed to support infantry and exploit breakthroughs, proving brutally effective in the flat, open terrain of France and the Low Countries. Its road speed was impressive for the era, easily reaching 42 kilometers per hour, allowing it to keep pace with the motorized infantry divisions that formed the core of the Lightning War. The German High Command relied on methodical, deliberate factory output, a national philosophy that demanded superior individual quality from every vehicle. Every rivet, every weld, and every engine was expected to represent the pinnacle of German engineering, a focus on Meisterstück, the master craftsman's piece, which prioritized technical quality over the vulgarity of mere volume. This approach reflected a belief that a small, highly effective armored force could achieve decisive victories, and in the spring of 1940, that philosophy was winning. Within 42 devastating days, France, a nation considered a great military power with a formidable, though poorly deployed army, had been completely routed and forced into a humiliating surrender. Britain stood isolated and bleeding, its entire expeditionary force barely escaping across the Channel at Dunkirk, having abandoned nearly all of its heavy equipment on the sandy beaches. The world watched in horror as the continent collapsed under the weight of German steel and speed.
At this precise, terrifying moment, the industrial might of the United States of America, the sleeping giant, was utterly disconnected from the catastrophe unfolding in Europe. America was a nation defined by its domestic consumer market, by cars, refrigerators, and quarterly earnings reports, not by tanks and artillery. Its factories were masters of peacetime goods. In June 1940, the entire U.S. Army possessed fewer than 400 modern tanks, and most of those were relics of an outdated military doctrine that viewed tanks as mere infantry support, not as independent, battle-winning weapon systems. The most advanced model in service was the M2 light tank, a fragile machine designed primarily for training exercises and basic reconnaissance. It was armed with a paltry 50 caliber machine gun and a relatively weak 37mm cannon.
The M2 Light weighed a mere 11 tons, a featherweight compared to the Panzer IV, and was an artifact of peacetime, utterly incapable of meeting the German threat head-on. The U.S. military-industrial base was non-existent. The nation had mastered the production of the sedan, the pickup truck, and the standardized consumer component, but the mass production of a battle-ready main battle tank was an alien, almost incomprehensible concept. The gap between what America could produce and what the war demanded was vast, and the fate of Western civilization hinged on closing it immediately.
President Franklin Delano Roosevelt, possessing a keen understanding of both strategy and industrial capacity, recognized instantly that the war would be decided not on the beaches of Normandy, but on the vast, deafening assembly lines of Detroit and the industrial heartland. He knew that America could not out-engineer Germany overnight, but it could certainly outproduce them over time, substituting quantity for the initial lack of combat-proven design. The national task was defined as becoming the arsenal of democracy, transforming the nation's peacetime, civilian-focused economy into a single-purpose war machine capable of supporting all nations fighting tyranny.
It was a profound psychological and economic challenge, requiring billions in investment, the halting of consumer production, and the mass retraining of millions of workers. To achieve this unprecedented feat, Roosevelt required a master builder, a man whose entire life had been defined by scale, efficiency, and the ruthless pursuit of mass production goals. He chose William S. Knudsen.
Knudsen, a burly Danish-born industrialist whose career traced the evolution of the modern assembly line, was nothing short of the undisputed king of American mass production, having risen through the ranks to become the former head of manufacturing for Ford and later the president of General Motors. He understood the rhythm of the assembly line, the flow of components, and the necessity of standardization better than anyone in the country.
On June 6, 1940, with Europe still smoldering, Roosevelt appointed him chairman of the Office of Production Management. Knudsen faced a task monumental in scope, transforming a civilian economy, one built on predictable quarterly profits, competitive market shares, and frivolous model year changes, into a non-stop, single-purpose engine of war, focused solely on survival. This meant converting paint shops into welding bays, body presses into hull stampers, and sedan designers into armor experts, all while navigating the immense political and labor obstacles that such a transition entailed.
The war required an immediate, quantitative response that stretched the imagination of even the most experienced industrialists. The British, desperate and facing imminent invasion after having left nearly all their heavy equipment on the beaches of Dunkirk, pleaded for arms that they could no longer manufacture themselves. The official target, set in the anxious summer of 1940, was a number that defied all previous military-industrial logic and dwarfed anything America had ever attempted: 500 tanks a month. This goal was not merely a production target, it was a political statement, a declaration that America was taking a side and committing its soul to the struggle.
This was the genesis of the greatest industrial mobilization in history. To achieve the 500-a-month quota, Knudsen needed to build an entirely new ecosystem from scratch, one capable of applying the revolutionary techniques of the automobile industry, interchangeable parts, continuous flow, and meticulous time management to the complex, heavy construction of armored fighting vehicles. He turned to the Chrysler Corporation, arguably the most flexible and innovative of the big three automakers, whose leadership was willing to take a massive gamble on the future.
The first step in achieving the almost unbelievable 500-tank quota was the creation of a manufacturing facility of unprecedented scale, dedicated solely to armor production, bypassing existing military arsenals, which were slow, tradition-bound, and stuck in a pre-assembly line mindset. The chosen location was a vast open field in Warren, Michigan, just north of Detroit, a site that was soon to become the legendary Chrysler Tank Arsenal. The vision was to create a tank factory that functioned exactly like a car factory, but on a superhuman scale. The construction timeline was brutal, a test of American willpower and efficiency. The first shovel of dirt was turned in September 1940, just as the Battle of Britain was raging in the skies over England.
The contract required the factory to be operational and delivering tanks in under a year. By bypassing bureaucratic delays, cutting through mountains of red tape, and employing the most rapid round-the-clock construction techniques available, Chrysler finished the main structure, covering a staggering 1.3 million square feet of floor space in just 333 days. It was a construction miracle performed under immense pressure, symbolizing America's entry into the war effort long before Pearl Harbor, a monument to the speed and efficiency of American capitalism turned to war.
The man in charge of overseeing this frenetic pace and translating automotive know-how into tank production was K.T. Keller, the president of Chrysler. Keller's true genius was his relentless pragmatism and his recognition that a tank, while complex and massive, was still fundamentally a machine that could be broken down into repeatable, standardized, and mass-produced components, much like a car. A paradigm the Germans, with their custom-built, artisanal approach, would never fully embrace. The challenge lay in applying the techniques of building a light passenger sedan to a 30-ton war machine, running massive hulls along tracks and applying overhead cranes with the efficiency usually reserved for engine blocks. But Keller's team managed it, designing flow lines that moved the heavy tank hulls from station to station with the same inexorable time clock efficiency as a Dodge chassis. The resulting factory floor was a vision of controlled chaos where thousands of workers moved in precise coordination, each performing a single, repeatable task that contributed to the final, rolling machine of war. The first tank to roll off this revolutionary assembly line in mid-1941 was not the ideal weapon. It was the M3 medium tank, known as the Lee by the Americans and the Grant by the British, names that would become synonymous with the desperate early days of the Desert War. The M3 was a solution born of extreme pressure and a terrifying time constraint. It was designed in 1940 under the stark realization that a tank with a powerful 75mm gun was needed immediately to counter the German Panzer IV, even if the design was fundamentally compromised. It was an exercise in improvisation, forcing a large gun into an existing chassis structure because developing a new turret ring capable of mounting a 75mm gun would have taken precious life-or-death months.
The M3 suffered from critical, undeniable flaws that would haunt the Allied tankers who drove them into battle. First and most prominently, its main armament, a powerful 75mm M2 cannon, the required caliber, was mounted in a sponsons, a fixed, angled mount in the hull. This meant the entire crew had to traverse the entire 30-ton tank, traversing the tracks and chassis, to aim the main gun even a few degrees horizontally, a crippling limitation in the fast-moving, reactive world of armored combat. Second, due to its desperate two-story design, featuring a smaller 37mm cannon turret mounted above the fixed 75mm gun, the M3 had an extremely high, almost comical silhouette. It stood 10 feet 3 inches tall, towering over the flatter, sleeker German designs, which were lower to the ground for better concealment. For Allied tank crews fighting in the flat, open deserts of North Africa, this made the M3 a massive, slow-moving target, a highly visible monument to Allied desperation, easily spotted and engaged by superior German anti-tank weaponry at extreme ranges. Third, and perhaps most brutally, early models were constructed using riveted armor plates rather than the superior welding techniques later adopted. Records show that when these plates were struck by high-velocity German shells, the internal rivet heads would shear off violently and become deadly secondary projectiles, flying around the crew compartment like shrapnel, a horrific phenomenon known as spalling. Flawed as it was, awkward, tall, and dangerous to its own crew, the M3 Lee was the necessary stopgap, the product of a forced march by American industry. It was a production solution designed specifically to fill the Allied armor gap until a truly modern, turreted tank could be standardized and mass-produced. The first M3s were delivered immediately via Lend-Lease and saw their baptism by fire with the British Eighth Army against Erwin Rommel's formidable Afrika Korps. At the pivotal Battle of Gazala in May 1942, the Grant variant, modified slightly for British service, gave the British a fighting chance, even as they were strategically outmaneuvered by Rommel's genius. The Grant was the first Allied tank capable of reliably engaging the Panzer IV at distances greater than 800 yards, essentially leveling the playing field in terms of firepower that had previously been dominated by the Germans. They were the tanks that allowed the Allies to survive the onslaught, to hold the line until reinforcements could arrive. The M3 proved a profound truth. Quality, even with compromised quality, could buy crucial, irreplaceable time for the perfect war-winning design to be developed.
The Japanese attack on Pearl Harbor on December 7, 1941, erased all remaining political hesitation and fully awakened the American industrial beast. The war was no longer about supplying allies, it was about national survival. The goal of 500 tanks a month, once considered a fantastical dream, was immediately discarded. It was now considered the bare minimum required to fight a global war. The new target was a staggering and almost incomprehensible 1,200 tanks per month, requiring a near-total restructuring of American industry. To meet this crushing new demand, the M3 was rapidly phased out in favor of a new design, one that incorporated the brutal lessons learned in the field and the revolutionary techniques perfected on the factory floor. The M4 medium tank, universally known as the Sherman.
The Sherman was never designed to be a technical marvel or a tank destroyer. It was designed to be the ultimate logistical weapon, a machine whose effectiveness lay less in its armor thickness and gun caliber and more in its overwhelming ubiquity and interchangeability. The design brief focused ruthlessly on an industrial philosophy that Germany simply could not match: standardization. The Sherman was deliberately engineered to be simple enough that it could be built by 11 different companies spread across the entire industrial landscape of the United States. These weren't just the big three vehicle manufacturers like Chrysler, Ford, and General Motors. They included unexpected players, monuments of American heavy industry such as Baldwin Locomotive Works, a steam engine manufacturer, and Pullman Standard Car Company, a railway carriage builder. This industrial distribution of labor, the ability to rapidly convert an entire spectrum of manufacturing facilities to build one single standardized platform, was the true American secret weapon. It meant that production was not centralized and vulnerable, but dispersed, resilient, and virtually immune to interruption.
By early 1943, the American industrial surge hit its full, devastating stride, achieving a production tempo that was terrifying in its intensity and scope. The initial, ambitious goal of 500 tanks a month was not just met, it was shattered into irrelevance. Production figures regularly topped 1,500 units per month, often reaching peaks of 2,000. The factories were not just building tanks. They were building an insurmountable lead, a tide of steel that was guaranteed to crush the enemy under its weight. This relentless production disparity is the ultimate and most crushing record of the war. German factories, operating under the highly specific, perfectionist, and time-consuming philosophy of quality over quantity, managed to produce a total of only 1,347 of their iconic Tiger Eye heavy tanks throughout the entire war. The complexity, the custom parts, the high-quality alloys, and the sheer time required to build just one of these complicated, highly engineered behemoths was massive, requiring thousands of man-hours and specialized labor. The United States, by sharp contrast, was building the same number of Shermans, 1,347 units, in just 3 weeks at the height of its industrial output. The total cumulative production of the M4 Sherman, a tank often derided by historians for its tactical shortcomings,
stands as the most damning statistic for the Axis powers, an astounding 49,234 units.
This incredible number, 49,234, is the definitive, irrefutable answer to how the German war machine was ultimately crushed. The victory was not achieved through a single, perfect piece of technology, but through the overwhelming, relentless, and standardized output of the American factory floor. The true victory for the Allies was won here, on the assembly line, in the vast, echoing caverns of the arsenal of democracy, long before the tanks ever engaged on the European front.
While the Sherman was an unparalleled logistical triumph, it was often disastrously outmatched in a one-on-one duel on the battlefields of Europe. German tanks, like the Tiger I and the later, more numerous Panther, possessed superior sloped armor and far more powerful main guns, particularly the high-velocity 75mm KWK-42 L-70 mounted on the Panther. This technical superiority gave the German tanks a crucial advantage in effective firing range, meaning a Panther could often destroy a Sherman from a distance where the Sherman's own gun, typically a 75mm M3, could not effectively penetrate the Germans' frontal armor. Records from the hedgerows of Normandy in 1944 often grimly confirm this disparity. It typically took the focused fire of 3 to 5 Shermans to reliably destroy a single Panther tank, often requiring flanking maneuvers or sheer luck. The American crews suffered tremendously, knowing their tank, affectionately and morbidly called the Ronson for its unfortunate tendency to ignite when hit, was vulnerable. They operated under a profound tactical disadvantage, yet they were sustained by a strategic reality that was the brainchild of American industry.
American strategy, dictated and enabled entirely by the industrial reality, was simple, brutal, and utterly effective. Overwhelm the enemy with sheer numbers. The German command, with their finite resources, had to worry about one Tiger engaging 3 or 4 Shermans, knowing that if the Tiger was lost, it was virtually irreplaceable due to the long, complex production cycle. The American command simply needed to ensure that for every Sherman they lost, they had 5 more waiting in the supply depots, and 5,000 more currently rolling off the assembly lines back home. This industrial attrition was the true crushing force. Germany's production of armored fighting vehicles peaked in 1944 at approximately 19,000 units, achieved under constant duress and suffering from a bewildering lack of standardization between production facilities. The U.S. total for the same year was nearly 30,000, and critically, the U.S. never had to divert significant resources to protecting its mainland factories. German production was constantly harassed, dispersed, and reduced by relentless Allied strategic bombing campaigns that targeted industrial hubs and transport infrastructure. The American factory floor was safe and humming. The German factory floor was a target, constantly scrambling to recover from the latest air raid, further preventing the standardization they desperately needed.
The sheer volume and standardization of Shermans also fundamentally altered Allied logistics on a global scale. The ability to ship thousands of standardized tanks and know that every bolt, every track link, and every engine part was interchangeable meant that Allied forces in North Africa, Europe, and the Pacific rarely worried about a lack of replacement armor or spare parts. The supply chain was a well-oiled machine, mirroring the assembly line itself. If a Sherman was knocked out or disabled, a new one, built to identical specifications in Detroit or Philadelphia, could be delivered and integrated into the unit within days or weeks. German forces, when a Panther or Tiger was disabled, had to wait months for a specific, often handcrafted replacement part to be shipped across a collapsing rail network, a logistical nightmare that crippled their ability to maintain combat readiness.
The American industrial victory was not just about equipping U.S. forces with a necessary, if flawed, medium tank. It was about equipping the entire Allied effort, turning the tide on multiple fronts simultaneously. The Lend-Lease Act became the monumental supply chain that sustained the war. The Soviet Union, which bore the crushing brunt of the Eastern Front fighting against the majority of the Wehrmacht, was a massive recipient of American armor. Records confirm that the U.S. sent over 4,100 M4 Shermans to the Soviet Red Army, where they provided crucial mobility, reliability, and firepower, operating alongside the Soviet-built T-34s and allowing Soviet industry to focus on their own designs. Similarly, the British and Commonwealth forces relied so heavily on the Grant and Sherman tanks that they often formed the backbone of their armored divisions throughout the African, Italian, and European campaigns. The ability of the U.S. to standardize production and then distribute that production globally was the ultimate logistical weapon that bled the German supply lines dry and ensured that every Allied nation had the tools to fight, creating an overwhelming, inescapable material superiority.
By 1945, the American industrial machine had achieved a level of sustained output that remains unmatched in human history. Beyond the 49,234 Shermans, the U.S. produced over 2.4 million trucks, creating the logistics tail that kept the armies moving. 300,000 aircraft, ensuring air superiority, and 41.4 billion rounds of small arms ammunition, the very lifeblood of ground combat. The initial anxiety-fueled goal of 500 tanks a month had not just been met, it had become a trivial footnote in a victory built on relentless, organized, and overwhelming numbers. The Panzer IV, later succeeded by the Tiger and Panther, was built on the German philosophy of individual, complicated, and often over-engineered perfection. The M4 Sherman, built on the American philosophy of standardization, simplicity, and mass production, was the instrument that broke the back of the German war machine. The arsenal of democracy did not win the war with the best designs, but with the most efficient factories. And in the industrial war of attrition that defined the Second World War, efficiency and overwhelming volume were the only qualities that ultimately mattered.
If you enjoyed this deep dive into the industrial precision of World War II, hit that subscribe button. Next, we're uncovering the design that was laughed at by shipbuilders. You don't want to miss it. This is the WW2 Archives.